Okay, so next look at the increments and total differentiation, differential. Okay, so we can see in the textbooks is on page 30. Alright. Okay, let's say for the function z, okay, where the function z is in terms of x and y. Okay, so if x increases by delta s and y is increases by delta y, then z will increases by delta z. Okay, where actually the actual delta z is given by the following equation. Okay, so we have delta z equal to the f x plus the increment delta x, okay, y also plus the increment delta y, okay, minus the original function lah, f x y. Okay, so from the differentiation, okay, hold on. Okay, from the differentiation definition, we know that, okay, so if the fx, okay, is equal to fx plus delta y minus the fxy over the delta x. Okay, for the fy here, okay, is basically fxy plus delta y minus fxy over delta y. Okay, so note that delta also is denoted as this triangle lah. Okay, some books they use the notation of triangle. Alright. Okay, so which is implies, okay, so if we bring the delta x, okay, so if we bring the delta x, okay, if I can do like this, okay, if we bring this delta x to the left hand side here, okay, so it become this equation. Alright, and same goes for the delta y. If we bring it to the right hand side, okay, left hand side, so you bring it, it will be like this. Okay, so the fxy plus delta y minus fxy is equal to fyxy delta y. Okay, so now if we take delta z, okay, so basically we know that the delta z, okay, is given by the formula. Okay, so basically we just use take this one here, okay, alright, plus this one. Okay, then, okay, delta z in short, okay, so we just take it this one, the fxy delta x plus the fy delta y. Okay, that is the increment for z. Alright. Okay, so if delta x tends to 0 and delta y is tends to 0, so it means that is the value of the increment is very small, then the increment of the delta x is denoted as dx. Okay, so the increment of delta y will be denoted as dy, and the increment of del z will be denoted as dz. Okay, so this z is denoted, basically is known as the differential of z. Okay, therefore the del z is equal to dz. Okay, so this is the case where the increment is very small. Okay, let's look at the next definition. Okay, alright, suppose z is equal to fxy and fy exists. Okay, just now we already look at the one independent variable only. Okay, but now we want to look at the two independent variable fx and fy exist. Okay, so delta x and delta y are the increment of the x and y. Okay, then the approximate increment of delta z is given by the following. Okay, and the total, okay, so we have this, and the total differential is given by this. Okay, right, so basically same thing. Okay, because we know that just now we say that, okay, we have the del z is approximate to the dz. Okay, so that's why we have the total differential here is dz equal to fx dx plus fy dy. Okay, so it's same as the approximate increment of del z here. Okay, alright. So how about for the three independent variable? Okay, so let's say we have the w equal to fxy. Therefore, for del w, we just add up one more term, which is the increment for the z, del z. Okay, and the total differential will be dw fx dx fy dy fz dz.